Congratulations to Rebecca. Next, we have Rich Sorkin, founder and CEO of Jupiter, not the planet, rather the company, who has an announcement. Come on up, Rich.
Thanks very much. It's really a pleasure to be here. Hopefully you can hear me in the back. I guarantee you my voice hurts you more than it hurts me. It's a double pleasure to be here today. First of all, it's my first time as an executive board member here in the thought leadership group that this room represents. And secondly, I'm a USC parent, so it's always a pleasure to be here. Jupiter predicts risk from weather and climate change, particularly around perils like flooding, wildfires, extreme heat, a number of other perils that are relevant on a globally significant scale. This is a slide from the recent World Economic Forum in Davos. It highlights the growing incidence and economic impacts of natural perils. I'm sure many people in the room are very familiar with the losses and the disruptions that are increasingly coming from these weather events, and not only are they significant, but they are at record levels and increasing very rapidly. This is a bit spiky. This is just US catastrophic losses in property on a year-by-year basis. Last year, $350 billion, almost 2% of US GDP, and the trend line, although spiky, is clearly up. So essentially what we do is predict using dynamical models. So these are physics simulations like the federal government and other national governments around the world use, plus machine learning to predict on a forward basis, 1 hour to 50 years into the future, these perils on what in the tech world we call hyperlocal basis, which basically means 1 meter resolution. So a given asset might have 4 corners, middle of 4 sides, and predict risk in all of those places for level of inundation in a severe weather event, both short-term for operational use as well as long-term for planning purposes. We took a step back about 2 years ago. We were just starting to think about this and said, what are all the things that are wrong with these kinds of peril modeling? For those of you that are watching the news or John Oliver fans, you know that in the United States and around the world, we actually do a really poor job of predicting these kinds of perils relative to many other industries like financial services or internet advertising. The modeling is somewhere between 5 and 30 years behind the state of the art. And so the first thing that we did was we assembled a multidisciplinary world-class team in all of the relevant areas, climate prediction, weather prediction, hydroscience, hurricanes and cyclones, machine learning, AI, Internet of Things, satellite sensors, and took essentially a blank sheet of paper to designing a new modeling infrastructure to leapfrog what's been done to date. So one of the problems with these peril predictions, including and especially flooding, where we started, is that the disciplines are very siloed. So our colleague at IBM yesterday talked about the siloed nature of many of these information systems. This is one of the most extreme instances of that problem, maybe on the planet. And so we have a team that's expert in the natural events, so storms, tides, precipitation, the terrain, both the natural terrain in terms of elevation, as well as the data related to the as-built infrastructure, and then also what the climate's going to look like and how that impacts weather down to individual metropolitan areas over the course of the next 50 years. And all of what we're doing is probabilistic, multiple scenarios. We can have what-if analysis. We launched the first flood score service in February of this year. We were very excited to be able to partner with a fellow executive board member for the Supply Chain Management Center, Randy Kendrick at Zeebeck. I think he was happy to see himself covered in the New York Times, front page of the New York Times story on that use case, which was basically site selection decisions for industrial warehouses in Charleston, South Carolina, a place that floods and the flooding's getting worse. So that was our first use case. We launched that. That product had a 6-month to 30-year window for real estate site selection. It's now in use in 2 of the largest cities in the country, several of the largest industrial and commercial real estate firms, and several insurance companies are evaluating the predictive accuracy of the model to use in pricing and underwriting limits, and 2 insurance companies have now invested in Jupiter. So this gives you, for the first time ever, I'm about to show flood score operations, unlike flood score planning, which is 6-month to 50-year time horizon, now deployed throughout the Atlantic coast. Flood score operations predicts 1 hour to 5-day flooding at 1 meter resolution. Very important point for those of you involved with ports and logistics is that the underlying functionality of flood score operations is being used today by the Port Authority of New York and New Jersey. That service was built by our team in their prior university roles, funded by NOAA and the Department of Defense over a 20-year period. We're essentially taking that short-term prediction service, integrating that functionality into Jupiter's entire cloud-based architecture, and rather than being limited just to New York, we're going to deploy this service all over the world, first in New York and Miami, and then over the course of the next couple of years in every major port city around the world. So what does it look like? We're now looking at Charleston, South Carolina. The center of this map is the downtown core. In the upper right, there's the Wando Welch terminal, and the area with all the icons, that's a shipping terminal. There's typically somewhere between 500 and 5,000 brand new cars there. It happens to be a flood-prone area. 5 feet of flooding with 1,000 cars. You can do the math on the economic impact of that. So this is essentially showing one of 3 scenarios, the most likely scenario. We also have the worst case and average probability scenario in the case of an impending weather event. And for each relevant critical asset for that shipping terminal, there's a specific flood prediction based on its elevation and the surrounding infrastructure and drainage and shape of the land terrain. Just as a reminder, concrete is way worse than wetlands if you want to avoid flooding. And we're rapidly turning our urban areas into seas of concrete, so flooding is getting worse for that reason, in addition to the changes in the climate. Down at the bottom, we see an hour-by-hour forecast of the expected flooding in one of the designated locations. And this prediction is updated 4 times a day, fed by the latest weather models from the European community, the United States, and a number of other services around the world that provide flood prediction, weather prediction. It's the same models that feed into the U.S. National Hurricane Center, which is staffed by people trained by the full-time team at Jupiter over the last couple of decades. The interface looks a lot like Google Maps, so we can zoom in. Now we've selected one particular asset. I think this is an electrical junction that feeds the entire terminal, and we can also see most likely worst case and average scenario for that asset, as well as a handful of other assets designated by the owner of the shipping terminal. And this kind of hour-by-hour update, or hour-by-hour forecast that's updated 4 times a day or more frequently, allows customers, whether it's a retail customer with a store they're deciding whether or not to close, or an airport deciding whether or not to close a runway, or a terminal where they're going to have to move high-value assets away from harm's way, to essentially delay very expensive brand impacting decisions about closure till the very last moment because they have much better information about this. And then lastly, we provide a dashboard that integrates in things like the security camera or the Twitter feed or other data from third parties. So I tried to whip through this pretty quickly. I think I had 5 minutes. I went maybe just a minute or over or so, but thank you again. I'll be here the rest of the day, and I'm on the risk panel, so if you want to hear more about these issues, I encourage you to come to the risk panel at 2:45 today. Thanks very much.